Absolute value. The absolute value or modulus mod x of a real number x is x's numerical value without regard to its sign. For example, mod 3 is equal to 3, mod minus 12 is equal to 12, mod minus 1.3 is equal to 1.3. You can see the graph of y is equal to mod x. Some important properties are mod x is greater than or equal to 0, mod x is equal to root of x square, mod 0 is equal to 0, mod minus x is equal to mod x plus mod y greater than or equal to mod of x plus y. Let us look at the three steps approach. General approach to solving equalities and inequalities with absolute value is as follows. First, open modulus and set conditions. To solve or open a modulus, you need to consider two situations to find all roots, positive, negative. For example, mod x minus 1 is equal to 4. Positive would be if x minus 1 greater than or equal to 0, rewrite the equation as x minus 1 is equal to 4. If x minus 1 less than 0, we can rewrite the equation as minus of x minus 1 is equal to 4. We can also think about conditions like graphics. X is equal to 1 is a key point in which the expression under modulus equals 0. All points right are the first conditions x greater than 1, and all points left are second conditions x less than 1. Solve new equations. X minus 1 is equal to 4 would give you x is equal to 5, minus x plus 1 is equal to 4 would give x is equal to minus 3. Check conditions for each solution. X is equal to 5 has to satisfy initial condition x minus 1 greater than or equal to 0. Point is equal to 0.5 minus 1 is equal to 4 greater than 0. It satisfies. Otherwise, we would have to reject x is equal to 5, and x is equal to minus 3 has to satisfy initial condition x minus 1 less than 0. Minus 3 minus 1 less than is equal to minus 4, which is less than 0. It satisfies. Otherwise, we would have to reject x is equal to minus 3. Let us look at the three steps approach for complex problems. Example 1, mod x plus 3 minus mod 4 minus x is equal to mod 8 plus x. How many solutions does the equation have? There are three key points here: minus 8, minus 3, minus 8, minus 3, and 4. So we have four conditions. One is x less than minus 8. So we would get, solving this, we would get x is equal to minus 1. The next condition is minus 8 less than or equal to x less than minus 3. Solving this, we would get x is equal to minus 15. The next condition is minus 3 less than or equal to x less than 4. Solving this, we would get x is equal to 9. The next condition is x greater than or equal to 4. So solving this, we would get x is equal to minus 1. We reject the solution because our condition is not satisfied. Minus 1 is not more than 4. The illustration also might help you understand how to open modulus at different conditions. Let us see another example. Mod x square minus 4 is equal to 1. What is x? Here there are two conditions: x square minus 4 greater than or equal to 0. which gives x less than or equal to minus 2 or x greater than or equal to 2. X square minus 4 is equal to 1, which gives x square is equal to 5. So x belongs to minus root 5 to root 5. Both solutions satisfy the condition. So, and when x square minus 4 less than 0, solving this we get minus 2 less than x less than 2. So, minus of x square minus 4 is equal to 1, which gives x square equal to 3. So, we get x, we have values of minus root 3, root 3. Both solutions satisfy the condition. Answers, the final answer would be minus root 5, minus root 3, and root 5. Let us look at some tips and tricks. The three steps method works in almost all cases. At the same time, often there are shortcuts and tricks that allow you to solve absolute value problems in 10 to 20 seconds. Thinking of inequality with modulus as a segment at the number line. For example, 1 less than x less than line 9. What inequality represents this condition? Solution is 10 seconds. Traditional three steps method is too time consuming technique. First of all, we find length 9 minus 1 is equal to 8 and center 1 plus 8 by 2 is equal to 5 of the segment represented by 1 less than x less than 9. Now let's look at our options. Only B and D has 8 by 2 is equal to 4 on the right side, and D had left side 0 at x is equal to 5. Therefore, answer is D, which is mod minus 5 plus x less than 4. Converting inequalities with modulus into range expression. In many cases, especially in data sufficiency problems, it helps avoid silly mistakes. For example, mod x less than 5 is equal to x would belong to minus 5 to 5. Mod x plus 3 greater than 3 is equal to x belongs to minus infinity to minus 6 and 0 to infinity. Thinking about absolute values as distance between points at the number line. For example, in the problem a less than x less than y less than b is mod a minus x less than mod x minus b. We have mod y minus a less than mod b minus y. We can think about absolute values here as distance between points. Statement 1 means that distance between y and a is less than y and b. Because x is between a and y, distance between mod x minus a is less than mod y minus a, and at the same time distance between x and b will be larger than that between y and b. So mod b minus y less than mod b minus x. Therefore, statement 1 is sufficient.